This video is about enol and enolate chemistry. Recall the Keto-Enol Tautomerization, where a ketone would convert into an enol. The only requirements for this to occur is to have a carbonyl and an alpha hydrogen available on the carbon next to the carbonyl. There's always some enol in ketones and vice versa, but know that the ketone is way more favored than the enol, so usually the ratio is like 99.9 to 0.1. However, we can increase the amount of enol available by changing the conditions. For example, under acidic conditions, there will be more enol than you would expect. Why is this? Well, under acidic conditions, a ketone will get protonated, favoring this tautomerization to form an enol. However, if you really want to skew the equilibrium, you add a base to your ketone. The base will remove the alpha hydrogen, leaving you with an enolate anion. The enolate exists in two resonance structures where the negative charge resides on the oxygen, as this is much more stable. However, as it is more stable, it is also less likely to act as a nucleophile, whilst the resonance structure with the carbanion is a much less stable species but way more nucleophilic, which gives us the reason why the enol and enolate chemistry is so interesting. Let's look at the conditions we need to form enolates. First, we'll look at the bases. So the stronger the base, the more enolate is formed. The strong bases you need to know are sodium amide, lithium diisopropylamide or LDA, sodium hydride, and butyl lithium, with the honorable mention of sodium hydroxide and potassium hydroxide as long as they are in the presence of heat. We also need an acidic alpha hydrogen. To figure out if an alpha hydrogen is a good acid, we just gotta focus on the conjugate base or the enolate that it forms and consider its stability. Or we can just look at the pKa's of said alpha hydrogens. Recall that the lower the pKa, the stronger the acid. Resonance rules still apply, so the more resonance structures the conjugate base has, the more stable it is. So it's safe to say that a diketone is going to be more acidic than a monoketone, as seen below. Any effect that decreases the electrophilicity of the carbonyls, and therefore decrease the amount of resonance that's able to occur, will also decrease the acidity of the alpha hydrogen.